Hello guys, and welcome to another video. Today we will continue learning about the C programming language and continue where we left off, which is about, excuse me, which is about strings in C. So one clarification that I want to make or correction is that C is a middle level language, not a low level one. That is because it is both a low level language and a high level language based on what we see on the left. Or on this, right? On this article. No, it's not an article, a summarizer. Okay. But, I called it lower level because it contained memory management. Okay, so it's not memory safe. We need to handle memory ourselves, wherein we want to remove a specific item ourselves, unlike in JavaScript, wherein those things are handled for you. All you need to do is give the logic. Okay, so let's try it out. Let's continue. Strings in C are actually arrays of characters, just like in JavaScript, I guess, because we can access them using bracket notation, and we can also, what do you call this? Access, no, we can also look through them, the strings. Let's see. Although using pointers in C is an advanced subject, fully explained later on, we will use pointers to a character array to define simple strings in the following manner. I see. This method creates a string which we can only use for reading. If we wish to define a string which can be manipulated, we will need to define it as a local character array. Oh, all right. So basically a fixed point. So how many letters or characters will this string have? And if we provide this, I think this will be inferred to us, or the C compiler will infer the length of the string here for us. So if we exceed this, for example, if we add a string or character here, it's one I think is that we will get an error if we do that. Let's see. This notation is different because it allocates an array variable so we can manipulate it. The empty brackets notation tells the compiler to calculate the size of the array automatically. Yeah. So basically let the compiler do its work for us. This is in fact the same as allocating it explicitly, adding one to the length of the string. I prefer it this way because we don't have to count, okay, how many characters does this string have? It's more readable and maintainable, in my opinion. It's the reason what the reason that we need to add one, although the string John Smith is exactly 10 characters long, is for the string termination. Oh, a special character equal to 0, which indicates the end of the string. The end of the string is marked because the program does not know the length of the string. Only the compiler knows it according to the code. Oh, so instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we need to add 1 to that. I see. So always add 1 to determine the length of a string. Let's see. We can use the printf command to format a string together with other strings. In the following manner, let's see. So char pointer name. This is a pointer, right? Yeah. So a reference to this means that it exists in memory somewhere in compile time. This string right here. Int age. Okay. So that our next printf statement will print in line. Yeah, makes sense. The function strLength returns the length of the string which has to be passed as an argument. Also, this is how we can get the length of a string. Okay, that's cool to know. String comparison. The function string and compare compares between two strings, returning the number 0 if they are equal. So this is the Boolean expressions in C, I guess. 0 for false. Oh no. 0 for true, 1 for false, I think. Yeah, because in here it's returning 0 if they're equal. Or different number if they are different. Wait. So it's not 1. Okay. The arguments are the two strings to be compared and the maximum comparison length. There's also an unsafe version of this function called strcomp, but it is not recommended to use it. For example, why though? Let's see. Strncomp, compare rather. So the name, we'll compare this variable name here with a string, hard-coded string. Then the for, what's the for doing? So the length of the string. Okay, there we go. So we will compare from which point, from the starting point until it's, from which, okay, let me rephrase that. From the starting point up until what specific length do we want to compare these two strings at? So for example, we start at 0, which is the 0th index, j, and then, or I guess in this case, it should be starting at 1. So 1, 2, 3, 4. So the whole letters. Okay. The function turnCat appends first n characters of source string to the destination string where n is mean, so minimum. So the n and the length of the string. The arguments passed are destination string, source string, and n. Maximum number of characters to be appended. For example, so you have 20, the maximum. So if we concatenate that, combine hello and world. So what's this tree here? The length. Define the string first name with the value John using the pointer notation, and define the string last name with the value Doe using the local array notation. What's the result here? Let's try to run this in this code down here. I'm quite curious. Let's see what happens. So we have, so the first one, which is what we printed, what's happening here? So the dest is hello and source is world. So we said 3. So okay. So we only want to combine the first 3 letters of whatever the second parameter is. So this is the string that will be appended to the string on the first argument. That's what I'm understanding here. So if we try to print source at the first print line here, we should get the original string or probably the cutout string. Let's see. Yeah, the original string. Okay. Just for that to execute. Yeah. So in here, what we're doing this time is, since the dest right here has been changed, we changed the value of dest to be equal to its original value plus the first 3 letters or characters in the variable named source. It would now be hello world. And on this line right here, we are adding another we are adding new strings or characters to that already changed variable named test. And in this case, we are adding all the values or all the characters in the variable name source. And we can also just specify, I think, 1, 2, 3, 4, 5, so 6. We should still get the same result if I'm not mistaken with my understanding here. There we go. Okay. So what happened here? Well, 20 is just a representation of the maximum amount of characters that a string can have. And in this case, we just specified it to be 6, which is its length, plus 1, because of what was mentioned above, is that there should always be an extra 1 to determine the length of a string for termination, which I'm not sure what its purpose is yet for now. But yeah, that's pretty cool. So one thing to note is the first argument in strncad would be the one that will be the one that is changed, or rather, is the one that will be changed. And the second argument will be the string that you want to append to the first argument, right here. And the third argument is how many characters of the second argument do you want to add to the first argument. Okay, so let's reset this and do the exercise to see if we really understood this. So you have a char name with 100 length. Okay, excuse me. Find the string first name. So char first name is equals to John, and this should be a pointer. Okay, this one would be char last name array notation. So how many characters are there in though? It'll be 3 plus 1 is 4. So that's so right. Okay, anyway. Let's see what we're doing here. So that's it. Oh no, why did we reset that? Again. Char first name to John. And then char last name. 4 is the length. So let's run that. Is that it? Oh, really? We don't need to do anything else. Let's see what's happening here. Oh, of course it's going to take us there. Okay, let's move on, I guess. Let's see. For loops in C are straightforward. So we are now in loops. Very nice. They supply the ability to create a loop, a code block that runs multiple times. For loops require iterator, iterator variable, usually noted as I, or you can do IDX, which means index. For loops give the following functionality. Yeah, okay. So we first initialize the variable that we want to check its value of for the whole loop, then the condition, whether to run the loop or not, and then the post method, or what do we want to do after the loop is finished? Well, we want to, for example, increment the initialized value. So let's see here. For example, if we wish to iterate on a block for 10 times, we write, yeah, here, we declare the variable that we want to iterate over. What is its initial value? Or the value that we want to check for conditions of. So here we want to declare I to be equals to 0. And then of the condition that we want to check if we want to run the loop or not, or rather the code block inside the loop right here, is whether the value of the variable I is less than 10. And after the loop finishes in here, or rather after each iteration of the loop is done, so after executing the code inside, when this condition is true, we want to increment I by 1. So now from 0, I will now become 1. So now we will check the condition again here. So 1 is less than 10? Yes, it is. So we run this code here. And again, on the next, we will increment 1 again, or I again, by 1. That will be 2. So next time, is 2 less than 10? Yes, run this again. So something like that. Let's see here. This block will print the numbers 0 through 9, 10 numbers in total. Yeah. For loops can iterate on array values. For example, if you would want to sum all the values of an array, we would use the iterator I as the array index. Yeah, makes sense. But I want to know if we can get the length of the array, just like array.length. So like dot notation, just like earlier with the string, wherein we were able to get its length with string length. Excuse me. I mean, I guess we don't really need it if we can explicitly set the length of the array, but you know. Okay. Calculate the factorial. All right. Let's see. So pretty much all we need to do is loop to I equals 0 as long as I is less than. So what is the length of the array here? Well, that would be 10. Makes sense. Plus plus I. So there are two ways to increment values using the shortcut plus plus. Okay, there's what we call post increment and pre increment. And you can check out my short if you have not, or if you are not familiar with that. Excuse me. So all we need to do is multiply factorial. So this is also a shortcut, although I'm not sure if this is allowed in C. But so what we're basically saying here is we want to take the variable factorial and assign it a new value equals to itself multiplied to whatever value that we want. So in this case, array I. So a shortcut for that would be asterisk equals. So we can also do that in the, no, not in division, I think, with subtraction and addition. So let's see if this works in C. Okay, very nice. There we go. We have accomplished a for loop in C. Nice. While loops. While loops are similar to for loops, but have less functionality. Why is that? A while loop continues executing the while block. So the code block inside it, here, as long as the condition in the while remains true. So basically, repetition of if statements, something like that. So if this condition is true, keep running this right here. For example, the following code will execute exactly 10 times. Okay. While loops can also execute infinitely if a condition is given which always evaluates as true. Yeah, okay. So this is useful for example, a command line interface wherein you are asking questions. Yeah, you are asking some prompts from the user. So you don't want to exit the um you don't want to exit the command line interface while you are asking for prompts, now do you? You can break out of it, however. So I guess this will be discussed exactly down here. Okay, let's see. Loop directives. There are two important loop directives that are used in conjunction with all loop types in C. The break and continue directives. Okay. Directives, I'm not sure. The break directive halts a loop after 10 loops, even though the while loop never finishes. Yeah, here we go, as you can see. So this is useful if, for example, yeah, as I've mentioned with the command line interface, we don't want it to exit until a user satisfies or fulfills a specific condition. For example, a user answers your prompt. Well then, if they did, then we want to break out of the loop. So something like that, break. Okay, let's see here. In the following code, the continue directive causes the printf command to be skipped so that only even numbers are printed out. All right. Okay. Or we can just have an if condition here to say that if n modulo 2 is equals to 0, we can just print it so that we don't have to add this directive here. But this makes sense. So modulo is pretty much what is the remainder of this value when we divide it. So for example, 3, so the n is 3, divided by 2, the answer would be 1. And what will be the remainder? Well, there will be a remainder of 1. So we divided 3 by 1, and there's still 1 left. And for example, we did that with 2, or with 5. 5 divided by 2 would be 2. However, there's still 1 left in that, or the value 1. So it'll be 2 plus 2 would be 4. So that will be 2 values of 2, and there will be the value of 1 left to form 5. And 1 would be the answer in the when we use the modulo operator. Okay, this is useful for example if you don't want to break out of an array. Okay, so you want to access each item in an array and you don't want to break out of it. So this is the shortcut to that, the modulo operator, wherein the first the is it called dividend or divisor? I completely forgot. Devise. Let me search it up. Okay, so this is the dividend. So the value, for example, is n, which is the dividend, and 2 is the divisor. So for example, if the length of the array is 2, and then we are at 0, then 0 divided by 2 is undefined. It cannot be done, I think, right? Yeah. So we should have also a condition if the n, if we're currently at 0, then we want to just, well, put 0 there. Just use 0. Meanwhile, when we are at 1, dividend is 1. When we divide it by 2, there will be remainder of nothing. No, yeah, the remainder would be 0. So then we will go back to 0, right? Mm-hmm. So, you know, yeah. 1 divided by 2 remain. Yeah, there's no remainder in that. Okay. Exercise. The array variable consists of a sequence of 10 numbers, okay? Inside the while loop, you must write two if conditions, which change the flow of the loop in the following manner. If the current number which is about to be printed is less than 5, stop printing it. If the current number which is about to be printed is greater than 10, we stop the loop, okay? Notice that if you do not advance the iterator variable I and use the continued derivative, you will get stuck in an infinite loop. Let's see here. So we want to loop through the array. Excuse me. So if we want to, okay, so let's make this readable. So const to be, oh, not const, int to be printed is equals to array I. So I guess it should be in snake case. So if to be printed is less than 5, where will we get? Oh yeah, we would get into an infinite loop because we will keep skipping over the loop whilst not iterating over the value I. So one way to do that, did it say that we shouldn't move the I here? Yeah, without changing the printf command. So we can just move the I up above. That's pretty much it. Then if to be printed is greater than 10, we break. So this should do it. Let's wait for the result, and there we go. So what did we do here? Well, unlike in for loops, we're in after the operation after the operation will be the only time that we increment or decrement or change the value of the variable that we want to check a condition for. In a while loop, we can place it anywhere we want. And in here, since this operation up here, which is the incrementation of the variable I, will be unreachable. So unreachable is a term that we can use if a code will not execute at times or at a specific condition, let's say. Then we want to actually move it above so that it's not unreachable, because we want this condition or operation rather, we want to run this operation for each iteration. So every time we loop through this while loop. Because if not, then we will be stuck in an infinite loop because it is then unreachable, or this will run and then again we would be stuck in the same value because we would not have incremented I, the variable I, by 1. So let's say we are at, for example, 5 here. No, less than 5. We are, for example, we are at 4. So to be printed, or the index of 4 here is 2, okay? So we are at the second index of the array. So the value of that would be 4 right here. Um, right here. So 4 is less than 5, right? Yes, continue. So if this variable I was not incremented above and it was down here, then we would then go to the next iteration of the loop whilst not changing the value of the variable I. So it's still not, so the value of I is still 2 or the second index. So now the value of this variable will still equal to the second index of the array, which is 4. So 4 is less than 5, we continue, and we repeat that over and over again until our computer crashes. Okay, let's move on to the next lesson. Functions, hooray! Let's see. C functions are simple, but because of how C works, the power of functions is a bit limited. Functions receive either a fixed or variable amount of arguments. Okay. Functions can only return one value or return no value. Excuse me. In C, arguments are copied by value to functions, which means that we cannot change the arguments to affect their value outside of the function. To do that, we must use pointers, which are taught later on. Oh. So we cannot change the value of the argument? Is that what's being said here? Okay. The function foo we defined receives one argument, which is bar. Right here is an integer. The function receives an integer, multiplies it by 2, and returns the result. Okay. To execute the function foo with 1 as the argument bar, we use the following syntax. Yeah, makes sense. So 1 times 2. In C, functions must be first defined before they are used in the code. Makes sense. So we cannot declare a function inside a function, a closure. Is that what it's saying here? They can be either declared first and then implemented later on using a header file, or in the beginning of the C file. or they can be implemented in the order they are used. The correct way to use functions is as follows. Oh, so we can declare them first. Or rather, we should declare them first. I see. Okay. All right. Let's see. Write a function called print big, which receives one argument, which is an integer, and prints the line x is big. Okay, where x is the argument. If the argument given to the function is a number bigger than 10. All right. Important. Don't forget to add a new line character at the end of the printf string. Let's see. Print big. So print big int num if num is greater than 10, print printf format specifier b for integers, right? Yeah. Or is it d? Oh, I completely forgot. Well, let's see. No. Oh, and we should have the line break like so. Let's see. Ambiguity new declaration of int print big. Oh, okay. What do you mean? Oh, void. Oh, okay, okay. It's because we're not returning something here. Okay, there we go. And what did we get here? Ah, X is big. Okay, there we go. There we go. Okay. So one mistake is don't forget to look at the initiated or instantiated or declared variable and see what its return type is. So that's the use of types really. That's why I came to like TypeScript. Okay, let's move on. Let's see what they have to offer next. Static is a keyword in the C programming language. It can be used with variables and function. Okay. By default, variables are local to the scope in which they are defined. Yeah, so they are only available in the scope. Variables can be declared as static to increase their scope up to file. So basically inside the file, so a global scope, I think it's what it's saying. As a result, these variables can be accessed anywhere inside the file. Yeah, yeah, this is because this makes sense right here. This is also happening in JavaScript because every time we declare a variable or every time we declare a variable inside the function, then that variable or the value of that variable is only available in that specific call right here. And when we excuse me, and when we invoke the function again, then this makes sense because we would have declared another variable because it's literally what we are saying inside this function. Every time we run this function, we want to declare a variable named count equals to be equals to 0. Excuse me. Yeah. So we can use a static. So static is it like this variable right here is available inside the function itself. So just like a static in classes in JavaScript. So it's not locally scoped. When it's only available inside that specific reference or call. Okay. By default, functions are global in C. If I declare a function with static, oh, interesting. So we don't need to import. So like modules, we don't need to use modules in C or what? Because they are global, right? Meanwhile, if you use static, that means it's only available in a specific file. While static variables have scope over the file containing them, making them accessible only inside a given file, global variables can be accessed outside the file too. So are there modules in C? I'm interested in that now. In this exercise, try to find the sum of some numbers by using the static keyword. Excuse me. What do you mean here? Ah, okay. Static int result is equals to 0. Return result plus no, or rather result plus equals no. They should do it. Let's see. Yeah, there we go. So what did they do here? Well, it's a very cool shortcut. So basically, declare the variable result to be equals to static. So that means this is available inside the function itself. Uh, it does not depend on a specific call. So for example, when we invoke an object, right? So new object or inside JavaScript, if there's a static, then that means, for example, object dot item, and the item is static. That means this item does not change in value, even if we declare a new instance of this object. I hope that made sense. Okay, we just try it out. It's how we learn. But anyway, yeah, nice. This is very cool. And now we are at pointers. Very nice. Let me drink a water for some moment. For a moment. Ah, excuse me. Okay, let's see here. Pointers are also variables and play a very important role in C programming language. They are used for several reasons, such as, yeah, okay. Pointer is essentially a simple integer variable which holds a memory address that points to a value instead of holding the actual value itself. So basically, it's saying or it's telling the machine that, okay, there is a specific, or rather, this is where the value resides, or something like that. The computer's memory is a sequential store of data, and the pointer points to a specific part of the memory. Yeah, okay. Our program can use pointers in such a way that the pointers point to a large amount of memory, depending on how much we decide to read from that point on. Excuse me. Let's see. We've all we've already discussed strings, but now we can dive in a bit deeper and understand what strings in C really are. Okay. So this instantiation or line of code means it allocates a local variable called name, which is a pointer to a single character. Okay. It causes the string John to appear somewhere in the program memory. initializes the name argument to point to where the j resides at, which is followed by the rest of the string in the memory. So basically, with a pointer, this means that John exists somewhere in memory, and the pointer is basically pretty much saying that this right here is somewhere in the memory, and that would be the variable name. That's pretty much how I interpret this. If try to access the name variable as an array, it will work, and will return the ordinal value of the character j, since the name variable actually points exactly to the beginning of the string. Okay. Since we know that the memory is sequential, we can assume that if we move ahead in the memory to the next character, we'll receive the next letter in the string until we reach the end of the string marked with a null terminator. Yeah, so that's basically why we need to add 1 to the length of the string earlier when we are declaring the length of the string with bracket notation. Well, I'm not sure what it was called, I forgot, but yeah, something like that. Let's see here. So basically, sequential means it is in sequence. Let's go to the next one, which is dereferencing. The act of referring to where the pointer points. So where does this point? Something like that. Instead of the memory address. We're already using dereferencing in arrays. Yeah, so is that bracket notation or something? But we just didn't know it yet. The brackets operator, okay, accesses the first item of the array. And since arrays are actually pointers, accessing the first item in the array is the same as dereferencing a pointer. Okay, dereferencing a pointer is done using the asterisk operator. Right here. Notice that we used the ampersand operator to point to at the variable a, which we have just created. We then referred to it using the dereferencing operator. We can also change the contents of the dereferenced variable. Okay, let's change the variable. We just changed the variable again. So basically, in here, this means that we are actually changing the variable that is being referenced in this variable named pointer to a. Or rather, when we change the value of a pointer, that means we are changing the value of the variable that is being pointed to by the pointer, which is here. We are pointing to a up here. So that is why this will print out 3. Oh, that's pretty cool actually. Although I'm thinking that this will cause scales if we don't handle it properly. Let me drink some water for a bit. That's good to know. Let's see, create a pointer to the local variable n called pointer to n and use it to increase the value of n by 1. So basically, pointer to the local variable n. Okay, so basically, okay, I keep repeating myself. Pardon me for that. I need to expand on my vocabulary. So technically, okay. Anyway, so what we need to do is increment the value of the variable named pointer to n. And when doing that, we will be incrementing the value of n as well. Okay. So pretty much all we need to do is declare int, which is a pointer to n, dereference that with the ampersand operator, like so. And now we can increment the variable name pointer to n by 1. That should do it. There we go. Okay, very nice. Let's move on to the next one, which is structures. Oh, finally, is this objects? I hope it is. C structures are special large variables special large variables which contain several named variables inside. Oh. Structures are the basic foundation for objects and classes in C. Okay, structures are used for, so basically there are classes, object-oriented programming, no? Serialization of data, passing multiple arguments in and out of functions through a single argument. So yeah, pretty much to shorten your arguments, you can have an object as an argument instead. So that's pretty useful. Is there such a thing as destructuring though? I'm curious about it. Data structures such as linked lists, binary trees, and more. Oh, nice. The most basic example of structures are points, which are a single entity that contains two variables, x and y. Let's define a point. Okay. Now let's define a new point and use it. Assume the function draw receives a point and draws it on the screen, or on a screen. Without structs, using it would require two arguments, each for every coordinate. Yeah, okay, so here is dot notation, finally. Nice. Type defs allow us to define types with a different name, which can come in handy when dealing with structs and pointers. In this case, we'd want to get rid of the long definition of a point structure. We can use the following syntax to remove the struct keyword from each time we want to define a new point. So basically with this, we define that the variable point or variable named point will be of type struct. So with that, when we declare it, we don't need to add the struct keyword and its properties. So basically TypeScript, I guess. Almost. Okay. Structures can also hold pointers, which allows them to hold strings or pointers to other structures as well, which is their real power. For example, we can define a vehicle structure in the following manner. Okay. Int model, car brand. Since brand is a char pointer, the vehicle type can contain a string, which in this case indicates the brand of the vehicle. Okay. Let's see. Define a new data structure named person, which contains a string called name and an integer called age. Let's see here. Oh, okay. Type def struct curly braces. So we have the name or char asterisk name, basically a pointer to name, and an int would be age. And the name for the struct is person. Right? Yeah. Okay, that should do it. Nice. We are getting somewhere. I'm liking C now. Let's move on to the next one. We have function arguments by reference. Oh, okay. Assuming you now understand the pointers and functions, you're aware that function arguments are passed by value. Yeah, by which means they are copied in and out of functions. Okay, but what if we pass pointers to values instead of the values themselves? This will allow us to give functions control over the variables and structures of the parent functions and not just a copy of them, thus directly reading and writing the original object. So pretty much, this means that when we pass, for example, a value inside a function as an argument, then this function's reference to that value would not is not the original value that was passed. So basically, this is a copy of that value. Okay. Meanwhile, if we pass in a pointer, that means we would be changing the value that was passed. Let's see. Hence, the local variable, which only exists within the function scope. So yeah, basically exists here. Therefore, incrementing it has no effect. Yeah, there's no effect when incrementing it. That's why most often we can do something like return plus plus n, which is a pre-increment. And I think that should be a static. Yeah. So just like what we did earlier when we were exercising the static keyword. But in this case, our situation is that we want to actually change the argument or the value that was passed, not return a new value, or rather a value that is inside this function. Let's see. However, this will work. And it's a pointer here which point to a memory address outside the function scope. Yeah, okay. So here it's ampersand, dereferencing, and here this means that we're accepting a value that points somewhere in the memory, which is here. And in here, I'm quite curious. Why do we need to add a parenthesis? The difference is that the second version of add one receives a pointer to the variable n as an argument. Yeah, and then it can manipulate it because it knows where it is in the memory. Yeah, makes sense. Notice that when calling the add one function, we must pass a reference to the variable n and not the variable itself. So basically here, when we pass in a variable with the ampersand operator, this means that we're referencing this variable. Okay? This is done so that the function knows the address of the variable, so basically in it, and won't just receive a copy of the variable itself. Let's see. Let's say we want to create a function which moves a point forward in both x and y directions, called move. Instead of sending two pointers, we can now send only one pointer to the function of the point structure. However, if we wish to dereference a structure and access one of its internal members, we have a shorthand syntax for that. Because this operation is widely used in data structures, we can rewrite this function using the following syntax. I prefer this one. But I guess this one makes sense. I'm not used to it though. Yeah, I prefer this one, that's for sure. Is there a performance difference here? Oh, it's just a shorthand syntax. Okay, I see. So basically, we take in the structure and point towards x and increment it by 1. So I think that's what's happening here. Basically, a literal meaning. Okay, point towards my property, which is x, and increment it by 1. So let's see here. We have a function called birthday, which adds 1 to the age of a person. Let's see. Okay, type def struct person. Void birthday person points to p, which is a person, right? Yeah. Person John, printf, John's name, birthday. Okay. So we declare void birthday, or is it up here? Oh, right, your function here. Okay. So in here, we have void birthday accepts an argument of person which points to p, like so. Or rather, the type of this, okay, not points to person, but rather the type of this argument is equals to that of the struct person or struct named person, and is a pointer to the argument that is passed. So basically, all we need to do is p point towards it, and then h plus plus, Or we can do something like this, if I'm not mistaken. Yeah, let's try that. Ah, okay. So maybe like that. Or will that not work? Probably not. Yeah. Oh, interesting. So it's only a post increment, huh? Interesting. But what if we tried it with not shorthand syntax, but with the longer syntax? So for example, of course, that makes sense because with this, there is no property such as an additional sign. Okay, that makes sense. We're gonna do something like this, right? Yeah, okay. Let's see here. Oh, we're getting much deeper, huh? Dynamic allocation. Dynamic allocation of memory is a very important subject in C. It allows building complex data structures such as linked lists. And I think quicksort is much more complex for me. It's my nemesis. Okay, anyway. Allocating memory dynamically helps us to store data without initially knowing the size of the data in the time we wrote the program. Let's see here. So this is what we're looking for. Instead of having a fixed amount of length, for example, in a string. Is that it? Yeah. So basically, we can have like give it access or what? Mhm. Let's see how it's done. To allocate a chunk of memory dynamically, we need to have a pointer ready to store the location of the newly allocated memory. Okay. We can access memory that was allocated to us using that same pointer, and we can use that pointer to free the memory again once we have finished using it. So this is what I'm talking about. Oh, I'm so excited for this memory management. Yes, I want to have fast applications. I'm quite enthusiastic when in making one. Once we have finished using it, okay? Let's assume we want to dynamically allocate a person structure. Person is defined like this, okay? To allocate a new person in the function myPerson argument. Wait, what? In the myPerson argument, use the following syntax. What is this? So this variable named person, which is a struct defined as a person, it's a pointer to that. It's equals to, huh, okay. This tells the compiler that we want to dynamically allocate just enough to hold the person struct in memory and then return a pointer of type person to the newly allocated data. The memory allocation function malloc or malloc memory allocation reserves the specified memory space. In this case, this is the size of person in bytes. Okay. The reason we write parenthesis person pointer for the call to malloc is that malloc returns a void pointer, which is a pointer that doesn't have a type. So basically this returns, so the type of the return value of this function is a void, no type. That's why we do this right here to say that the type of whatever is returned here would be the type of the struct defined as person, and it is a pointer to that, right? Let's see. Writing this syntax in front of it is called typecasting and changes the type of the pointer returned from malloc to be person. Yeah, there we go. However, it isn't strictly necessary to write it like this, as C will implicitly convert the type of the returned pointer to that of the pointer it is assigned to. I see. So this is pretty much the same as like in TypeScript, almost, wherein have you add a colon here beside the variable name and type in the type of the variable. Something like that, but I think this is stricter. I'm not sure, but yeah. Excuse me. Note that size of is not an actual function because the compiler interprets it and translates it to the actual memory size of the person's struct. Ooh. To access the person's members, we can use the hyphen arrow notation or angle bracket. After we are done using the dynamically allocated struct, we can release it using free. Okay, note that the free does not delete the myPerson variable itself, it simply releases the data that it points to. The myPerson variable will still point to somewhere in the memory, but after calling myPerson, we are not allowed to access that area anymore. We must not use that pointer again until we allocate new data using it. So basically what this means is that this myPerson variable, after calling free, the data which it points to is now removed. However, that variable itself, or this variable itself, it still exists in memory. It's still pointing towards something. But what is but what's rather but what is it pointing towards to? I'm curious in that. Okay. Let's see. Dynamically allocate a new point struct, which my point points to here. Although should be just copy the syntax. Okay. So point asterisk and malloc the size of the point structure, right? Yeah, that should do it. And we did it. Excuse me. Very nice. Okay, one last, and then that will be it for today. Let's see. In a previous tutorial on pointers, you learned that a pointer to a given data type can store the address of any variable of that particular data type. For example, in the following code, the pointer variable PC stores the address of the character variable C. Well, yeah, okay. Makes sense. They just changed the variable name, pretty much. Here, C is a scalar variable that can store only a single value. However, you are already familiar with arrays that can hold multiple values of the same data type in a continuously, I think this is mistyped, allocated memory block. So you might wonder, can we have pointers to arrays too? Well, yeah. Let us start with an example code and look at its output. We will discuss its behavior subsequently. Subsequently. Okay, let's see. Vowels points, so this points to the array vowels, okay? So we have I, we print I, and print a reference or a dereference to the array right here. Then print I again, and then print the value of this right here. Let's see. Why are we getting hexadecimals? This is a hexadecimal, right? When you have a x, 0x. Meanwhile, here, oh, okay. Interesting. Oh, okay, now I don't know what's happening here because I have not really studied hexadecimals. Let's see. Different reference here. Oh, oh, it's a memory location. Okay, that's why it's very long. Okay. 1 byte so that the consecutive memory addresses are separated by a single byte. We also created a pointer, p vowels, and assigned the address of the array vowels to it. P vowels plus I is a valid operation, although in general, this may not always be meaningful. In particular, the output shown above indicates that the referenced value of vowels bracket notation I, p vowels plus I are equivalent. Feel free to alter the data types of the array and pointer variables to test this out. If you look carefully at the previous code, you will notice that we also used another apparently surprising notation, vowels plus I. Okay. Oh yeah, here. Interesting. On the other hand, ith element theory vowels. What? They're the same. Oh, address. Okay. Mm-hmm. By now we know that we can traverse an array using pointers. Moreover, we also know that we can dynamically allocate contiguous memory using blocks pointers. These two aspects can be combined to dynamically allocate memory for an array. This is illustrated in the following code. Okay. So here we create the integer 5 and the p vowels. Where's the char? Oh, okay, this is a type of char, excuse me for that. So we have a char and the length of the char b equals to n right here. So 5. Yeah, makes sense. So this is how you can create arrays, I think, dynamically. Okay. Oh, this is actually what I've been looking for most of the time. Is that when I have the length that I want, you know. Well, I guess you can do that in JavaScript as well with the new array constructor. But yeah, let's see. In the above code, we allocated 5 contiguous bytes of memory to store 5 characters. Subsequently, we use array notations to traverse the blocks of memory as if p vowels is an array. However, remember that p vowels actually is a pointer. Yeah, it's a pointer. Pointers and arrays in general are not the same thing. So when is this useful? Remember that while declaring an array, the number of elements that it would contain must be known beforehand. Yeah. Therefore, in some scenarios, it might happen that the space allocated for an array is either less than the desired space or more. Yeah, so basically doing this is pretty much you having the powers of lists or arrays in JavaScript, or I think Rust, the vector one. Yeah. Meanwhile, the array here, when we declare it, is a fixed point, right? Yeah. Moreover, unused memory can be freed as soon as it is no longer required by invoking the free function. On the downside, with dynamic memory allocation, one must respond to, yeah, okay, so this is memory management pretty much, forever relevant. Otherwise, memory leaks would occur, okay? Excuse me. We conclude this tutorial by looking at dynamic memory allocation for a two-dimensional array. This can be generalized to n dimensions in a similar way. Unlike one-dimensional arrays, where we use the pointer, in this case we require a pointer to a pointer, as shown below. Okay. Let's see what's happening here. We have the amount of rows, the amount of columns, and this right here is just for iteration. So we make an array that, oh, interesting. So for multi-dimensional arrays, we need 2 pointers. Is that it? Yeah. So basically, the first one points to the outside, the second one points to inner. Okay. Okay, so multiply this to the amount of rows, pretty much how many arrays do we have in this array. Okay, and then we get that back. Okay, and then the first item inside of that will be equals to an array, or we allocate 5 items for that list or array, and the same for the second one. Interesting. Oh, I'm liking this. Somewhat difficult a bit if you have no experience in, well, arrays, but this is pretty understandable, although I want to know more about malloc, the malloc operation here. Okay, so it's pretty much collecting the, or assigning values for each of them with bracket notation. So let's see. The first 7 rows of Pascal's triangle are shown below. Note that row I contains I elements. Therefore, to store the numbers from the first 3 rows, one would require 1 plus 2 plus 3, 6 memory slots. So 1, 2, 3. 3 rows, so yeah, 6. Complete the skeleton code given below to store the numbers from the first 3 rows of Pascal's triangle in a 2-dimensional array using dynamic memory allocation. Oh, okay. Wait, is that how we can enlarge this? Wait, where's it? No. This is a very small code editor. Oh, if I do find a compiler, that's good. And we will be coding in VS Code. Or I'll try Vim soon. It should be fun. Okay, anyway. Find the 2D pointer variable here. What's the name of that? So I can name it anything. Should be that, right? Then char. Is it char or is it a number? No, it's a number. What can we call this? Maybe 2D. Okay, anyway, we have int. Oh wait, we already have it. So there we go. That's how we do it, right? Let's see up here. Oh no. Should be. Is it the same thing when we like make it stick together or separate it? I think it's the same thing. Let's do it this way. Malloc. So that would be 2 times size of, what are we comparing to? 2-dimensional array. Oh, okay. So we just need to allocate 2. There we go. Right? So right here. Oh wait, define the 2D. Okay, so we just need to define it. Oh, my bad. There we go. Oh, it's named p numbers. P numbers. Break the following line to allocate. Rounding 3 rows. Oh, 3 rows. Okay. 3. Then here, allocate memory for storing. Oh, excuse me. For storing individual elements in a row. So pretty much, second item in the p numbers array was to int. Oh wait, we are storing 3 items, right? So it should be 3 pointers, if I'm not mistaken. We'll see, we'll see. It might be just 2, but let's see later. Oh, so you can still get the size of an int. Interesting. Okay. 2 equals to int. To do free memory allocated for each row. So that would be free numbers I. Is that correct? Yeah, here. And then read the top level pointer. Okay. That should do it, right? Let's try. Or probably this is wrong here. But I'm guessing it's like add. Oh yeah, okay. It's only 2. Where's the error? There. P numbers 1. Limit. Ah, okay. It's a typo error. Okay. Expected a colon before limit. Oh, okay. Right here. I should do it. A semicolon rather. Oh, there we go. Interesting. So, right, because this is pretty much 2-dimensional, not a 3-dimensional array. Okay. It's just that we have 3 items or 3 arrays. Or 3 rows in this case. But it's still 2-dimensional. Okay, that makes sense. Okay. Wow. We did it. Very cool. So we managed the memory ourselves as well. And congratulations, we learned pointers and C, hooray. Well, I think it's not everything, but yeah. I'm excited to build a data structure here. And I'll add it to my repository of data structures as well. So like I have 2 versions right now, which is written in Rust and TypeScript. I might write one in Go as well. Yeah. But I haven't written the linked list in Rust, have I? I haven't yet. Yeah, I think I might make some. I might turn those into a command line interface wherein we can have like tests, prompts that will check or ask us, what do you want to run? What kind of data structure do you want to run? What's the kind of language? Yeah, I might make a game out of that. Command line game. Oh, that should be fun. Okay, anyway, I'm getting carried away here. You know what? I think I might make a video about that. Making a command line interface in C, maybe? Or is that too difficult? Maybe we can do it in Rust. Okay, anyway. So we have learned pointers. I think that's just the surface level of it. We might get deeper into this after we surf through this article. Oh, we have Shell. I might study Shell as well. Maybe Java. Oh, who loves Java, you know? Anyway, that's all for today, and I hope you learned something as I have learned about pointers, which is very neat. And we will tackle recursion in the next C programming video wherein I study this or surf through this article. Is it really an article? No, a website rather. And yeah, thank you for watching. I hope you have a good day and good luck on your development journey. Happy learning. Bye bye.